Alrighty, in this video, we'll be looking at chapter 6, matrices and determinants and applications. And we're going to be looking at section 6.1 today, which is solving systems of linear equations using matrices. All right, the first example we're going to be doing, I guess first let's do objective 1. Which is write an augmented matrix. All right, and basically what we're going to be doing is trying to get it in the form, the standard form, as if we're about to do addition elimination method. And then we're basically just going to take all the numbers and put them in a what looks to be a bracketed box. So if we look at this first example, we'll have 2 times y minus x equals 4 minus 8x. And then we have 5y equals 6 minus x. So again, our first objective is to get it in standard form, which is, if you don't know, ax plus by equals c. And to do that, we need to distribute so that we get 2y minus 2x equals 4 minus 8x. And then I'm going to move the 8x over. So that gives us 2y plus 6x equals 4. And then over here, all I got to do is just add the x. So I get 5y plus x equals 6. And I guess what I need to do to correct this is I need to put it in ax plus by equals c. So to do that, I'm going to rewrite both of them as 6x plus 2y equals 4 and x plus 5y equals 6. To turn this into an augmented matrix, you will have a bracket here, and you basically will have a column of all your x values. For the first equation, I have 6 x's, and for the second equation, I have 1 x. Your second column is your y's, so you'll see that you have 2 y's in the first equation and 5 y's in the second equation. Then we follow this by with a straight line. This actually represents the equal sign. And then we'll actually write down what they equal. The first equation is equal to 4. The second equation is equal to 6. And then we will close out the bracket. That right there is what we call an augmented matrix. And that's all you have to do in the first objective. I say that that's the first part of the first objective. The second part is to go backwards. So if I give you an equation or an augmented matrix that follows 1, 0, 0, 2, 0, 1, 0, 6, and 0, 0, 1, negative 1/2, the rules stay the same. This is still my column of x's. This is my columns of y's. This now becomes my columns of z's. This is still my equal sign, and this is what it's equal to. So to convert these into equations from an augmented matrix, I have 1x, no y's, no z's, and it equals 2. In the next equation, I have 0 x's, 1 y, 0 z's, and it equals 6. The third equation, I have 0 x's, 0 y's, 1 z, and is equal to negative 1/2. And that right there would be your answer. So that's all you have to do in the first objective. Alrighty. In the second objective, you're just going to use some elementary row operations. So we're going to start off basics. So use some elementary row operations. All right, so if I give you this augmented matrix, 1, 5, 6 equal to 2, 2, 1, 5, and I equal it to 1, 4, negative 2, negative 3, ran out of room there, and I equal it to 10. What I want you to do first is I want you to hold on, let me make sure I understand these symbols here. I want you basically, when you see something like this, R1 represents row 1. But when you see this symbol right here, it means to interchange these two rows. So this would be R2, which represents row 2. Interchange is just a fancy word of just saying switch. So I'm going to switch row 1 with row 2. So basically this is row 1, this is row 2, and this is row 3. So my answer here, if I ask you to do this, I'm just going to switch the second row and the first row. So my new augmented matrix is now 2, 1, 5 equals to 2. Oh, my bad, not 2, 1, 5 equals to 1. And then 1, 5, 6 equals to 2. And 4, negative 2, negative 3 equals 10. All I literally did is switch everything in row 1 with everything in row 2. And that's it. If I take that exact same equation and I ask you to, using the original one here, take half of row 2. So I'm going to multiply every number in row 2 by half. And I'm going to replace that row in row 2. So basically what this stating is I'm going to half everything in row 2 and replace it with the answers of row 2. So what that means is that row 1 will remain unchanged. I'm using the original augmented matrix. This is a separate question. And row 3 will remain the same. And what this means is I'm going to take half of every element in row 2. So 2 times a half is 1. This then means I'm then going to write the result in row 2. So half of 2 is 1, so that new result goes there. Half of 1 is a half, that result goes here. Half of 5 is just 5 halves, so that result goes here. Half of 1 is a half, so that result goes here. So again, all this means is I'm going to take half of row 2, and I'm going to write the results in row 2. If I ask you a third separate question here, I tell you to multiply row 1 by negative 4, then add it to row 3, and replace the row 3 with that answer. So again, I'm going to multiply row 1 by negative 4, add it to row 3, and I'm going to write my answer as my new row 3. Again, using the original augmented matrix. So what this does, this tells me that row 1 remains the same, because the only thing that's being changed is row 3. Row 2 will remain the same. And now I'm ready to make my new row 3 by multiplying row 1 by -4. So -4 times 1 is -4. And then add it to row 3. So -4 plus -4 gives me 0. I then write the result in row 3. So I do it again. -4 times 5, which is -20, plus -2 gives me -22. Do it again. So that's going to be -4 times 6, which is -24, plus -3 gives me -27. Do it again. -4 times 2 is -8, plus 10 gives me 2. That is basically what this stated. Again, I'm multiplying row 1 by -4, adding the result to 3, and writing the result in row 3. All right, and that's basically what you do in the second objective. In the third objective, we're going to use what we call Gaussian, man, I forgot the word already. Get Gaussian's elimination, something like that. Gaussian. I have to look it up. So this game, elimination. And Gauss Jordan. Elimination. All right, so here we go. So if I gave you an example, 2 times x minus y equals 4x plus y minus 40, and 9y equals 105 minus 3x. Our first goal is to get this into an augmented matrix. So I'm going to distribute first. So this will give me 2x minus 2y equals 4x plus y minus 40. I'll then go ahead and subtract 4x and subtract y. So this will give us negative 2x minus 3y. This will all go away, equals negative 40. It is now in standard form. All I gotta do here is add 3x here, add 3x here. So this will give me 3x plus 9y equals 105. So here's my standard form. So I'm gonna rewrite them as negative 2x minus 3y equals negative 40, and 3x plus 9y equals 105. Turn this into an augmented matrix. I have negative 2x's and 3x's on the other one. My y would be negative 3 and 9. And this would all equal negative 40 equal to 105. All right. It's actually straightforward with these type of matrices. It's when you get a little bit bigger, which we'll see in the next example, that becomes a little bit more tedious. Your first goal is to make this guy become a, how do you want to put that? Easiest thing I've seen is to turn this guy into a 0. And the way we can do that is you will basically, okay, I'll write the result here. I'm basically going to take this result, this number, and multiply row 1 by it. So that'd be 3 times row 1, and then add it to the multiplication of this guy to row 2. So again, I'm going to take 3 times row 1 plus -2 row 2. This is a lot like the addition elimination method, where we're trying to eliminate a variable, but in this case, we're specifically trying to eliminate this x value. So I want to write the results in R2. All right, so just like we've been doing before, this will then give me, the first matrix will stay the same. Or sorry, the first row will stay the same. And then I'm just going to work the formula I got here. So 3 times -2 is -6. -2 times 3. Oh, that's right. If we recall, we have to change the sign, right? Because that would be -6 and that'd be -6. So I'm going to change this guy to a positive because the goal is for it to eliminate. There you go. And a good check would be when you do the math and you don't get 0, go back and either change the sign or change the numbers. So 3 times -2 is -6. And then 2 times 3 is +6. -6 plus 6 is 0, which is what we wanted. 3 times -3 is -9. 2 times 9 is 18. -9 plus 18 is just 9. 3 times -40 is -120. I'll do a little side work over here. So -120. And then 2 times 105 is 210. And then -120 plus 210 would be 90. All right. Step 2 is to then turn this guy into a 1. Easiest way to do that is take whatever that row is, which in this case is row 2, and divide it all by 9 and make that your new row 2. So therefore, when I do this work, row 1 will remain the same. And then 0 divided by 9 is 0. 9 divided by 9 is 1, which is what we wanted. If we don't get 1, we need to rethink this. And you don't want this guy to turn into anything other than the 0 you originally had, because then you'd be going backwards. And then 90 divided by 9 is 10. Now, if you recall, this is my x and this is my y. So this bottom equation tells me that my y is equal to 10. So with that being said, I can now back substitute it into this equation to solve for my x. So I'm going to come up here on my side work I got going on. So that'd be -2x minus 3 times 10, because that's what my y would be, equals -40. And so that gives me -2x minus 30 equals -40. And then I'm going to add 30 over. So that gives me -2x equals -10. Then divide by -2. So x equals 5. So our answer here would be 5, 10. And so that's how you can use matrices to help you solve it. This is where you basically just get a triangle of zeros here, which in this case, it's just one little 0. And this is half of the way. There is something called row reduced echelon form, which will then have zeros on both sides. But in this case, you don't have to go all the way with it. Once you get one letter, you can start back substituting in. All right, in this last example, I'm going to show you one where it is. I've forgotten one. And it's a 3 variable one. So this would be a 2x minus 8y plus 54z equals -4. X minus 2y plus 14z equals -1. X minus 3y plus 19z equals -3. And again, I'm going to turn this into an augmented matrix. So I'm going to write my x's first. That gives me 2, 1, 1. Write my y's. So that gives me -8, -2, -3. Take my z's. I got 54, 14, 19. And then that would just be -4, -1, -3. All right, so just like before, my first goal is to get this guy to turn into a 0. And it looks like the best route to do that is to basically take row 2 minus row 3 and make that my new result. So I'm going to take row 2 minus row 1. Doesn't matter which way you go. You can multiply, whatever you wanted to do here. But the goal, again, is to get this guy to be a 0. I want to add that to row 3. And I want the result to be in row 3. So here we go. The first 2 rows stay unchanged. All right, so 1 minus 1 is 0, which is what we wanted. -2 minus -3, that makes it a positive, so that actually ends up being 1. And then we get 14 minus 19, which is -5. And then -1 minus -3, that will give us +4. Oop, I lied. -1 plus 3 is 2. 14 minus, okay. It does get tricky with the math. It's just simple math that can mess up. All right, the next step is then to get this guy to be a 0. The best way to do that is take row 1, sorry. And you want to basically take whatever this result is and multiply. You're going to basically do the same thing we did earlier. Take this number, multiply it to this, take this number, multiply it to this, but then you want to change the sign. So I'm going to say row 1 times 1 will just be row 1 minus, I'm going to change the sign, 2 times row 2. All right, so that right there should 0 out because I'm trying to 0 this guy out and I want to put the result in row 2. So here we go. So row 1 will remain the same. So, and then row 3 will remain the same. All right, so here we go. So 2 minus 2 times 1 is just 0. Then you have -8 minus, this would be +4. So -8 plus 4 is -4. And then you have 54 minus 28. What is that? 26. Woo, simple math. Yep, 26. All right, gives you 26 here. And then you have -4 plus 2 is -2. All right. Your next move is then you want to make this guy become a 1. And the best way to do that is just do row 2 divided by -4. and put it in row 2. So now that's going to give me 2, negative 8, 54, negative 4, 0. Negative 4 divided by negative 4 is 1, which is what we wanted. 26 divided by negative 4 looks like it's going to give us negative 13 over 2. And this right here would be positive 1/2. And then we get 0, 1, negative 5, and 2. All right, our last step before we can go back and substitute in is we want to turn this guy into a 0. And then we're just basically just going to subtract the two fractions. All right, so that will mean that row 2 minus row 3 will be my new row 3. And when I do that, I get 2, negative 8, 54, negative 4. Then I get 0, 1, negative 13 halves, 1/2. 0 minus 0 is 0, which is good. We don't want to change anything we've already worked on. 1 minus 1 is 0. Negative 13 halves minus 5 halves is the same thing as negative, actually 2 negatives to make a positive. So that'd be negative 13 halves plus 5, which is 10 halves. So that'd be negative 3 halves. And then, shoot, where we at? So then we can take 1/2 minus 2, which will be negative 3 halves. Huh, cool. All right. After that point, we now have a one last step, I guess. And that's just to make this guy become a 1. The best way, again, to do that is take that row, divide it by whatever that number is, and we get this guy. Zero divided by that is 0. 0 divided by that is 0. The exact same thing would just be 1, and the exact same thing would just be 1 again. All right, so what this tells me is that z, because again, this is your x, y, and z, tells me that z is equal to 1. And knowing that, I now have y plus negative 13 over 2 times 1 equals 1/2. So I'm basically just going to have y minus 13 halves equals 1/2. And then I'm going to add 13 halves over. So that right there would be 14 halves, which is 7. Since y equals 7, I can then go back to the original one. And so I have 2x minus 8 times 7 is 56, plus 54 times 1, which is just 54, equals negative 4. Well, negative 56 plus 54 is negative 2. Add the 2 over, so I get 2x equals negative 2. Divide by 2, I get x equals negative 1. So my answer here is negative 1, 7, 1. So we can use echelon or the Gaussian elimination to get to a point where we solve basically for 1 and then back substitute in. The other way is I have seen a lot of people require you to also turn this guy into a 1, which would make these numbers a little bit smaller. But at the end of the day, I think as long as you get to this point, the rest of it doesn't really matter. All right. And there you go. That's it for 5.6. Oh, my bad. 6.2.